Hey, Chris here. Quick little review of Unit 6, Activity 7, and a little backwards review to start off. Remembering that if we had all three angles in a triangle together, they had to 180 degrees. Nice little visual there. Okay. In a right angle triangle, we can label hypotenuse because it's opposite the right angle. But without a 90-degree angle, I can't label an opposite, which means I wouldn't be able to use these three formulas. Okay, so just be careful that we're only using SOHCAHTOA if we have a right angle and an opposite. Okay, we can also only use Pythagorean Theorem if there is a hypotenuse. And remember that this side would be h. The other two doesn't really matter. You can call them a and b, you can call them c and d, it doesn't matter. But it's this squared, h squared, that equals the other two squared. Okay, and really h is just a huge square, which is h by h, and then the b, I don't have enough room on here, would be a square that's b by b, and the a would be a square that's a by a, and this area plus this area equals this area. And that's why it's h squared equals a squared plus b squared. Okay, next slide. We're looking at labeling the triangles, just reviewing how we do this stuff. Okay, so as we label the triangles, we're going to make sure that we're going to say, okay, if I have a 90-degree angle, then I can label hypotenuse. And then I want to decide how I want to label this triangle. If I have a hypotenuse, no problem to do that one first. The opposite, I can put either side, but once I put the opposite in there, I'm stuck to doing my calculation using the 60 degrees. Okay, because it's opposite of the 60 degrees, so that's the angle I'm going to have to do all my calculations with. And then the adjacent's the guy left over. Okay, so if I'm going to label it out, the opposite is going to be based on the angle I want to calculate with, or that I want to find. All right, the next one over here is talking about the sine law, and we looked at the sine law and the cosine law, and I would just say that if we're talking about A as being this angle here, which I'm highlighting in green, if that's angle A, we remember that the side over here then must be side A because it's opposite angle A. Okay, so just careful on our labeling. And then we've got sine law if we want to find the angle, and cosine law if we want to find the side. They're the same formula, it's just easier with the unknown on the top. Okay, cosine law is going to be c squared equals a squared plus b squared. Notice that's the same as the Pythagorean theorem. And then we have this minus 2ab cos c to take into account that the c is not 90 degrees. Okay, if it was 90 degrees, this would work out, but cos of 90 is 0, so this piece at the second half will actually disappear. That's just Pythagorean theorem. Okay, so let's try one of these. Review number 1 here. And I'm going to go ahead and label it. It doesn't really matter which way I label it. I'm going to call it x, y, and z. I wasn't told that x had to be 120 degrees, so I'll put them any order I want. But now that I've got the sides, I know that if that's big X, then little x has to be over here. If big Y is there, then little y has got to be opposite him. And if big Z is over there, then little z has got to be opposite him. And then I'm going to go through my formulas to say, what do I know and what do I want to know? So I want to know, in this case, x, okay? So I'm going to rewrite this formula. I'm looking for a side. I'm going to rewrite it as x over sine x equals y over sine y equals z over sine z, because I want it to match rather than using a's, b's, and c's. Okay, so now I'm looking for the x, so I'll put a little question mark on there. I have big X, I have little y, I have little z. And I realize I don't have enough information. I can't use one of these because I don't have 3 out of the 4, so I'm going to have to look at the other formula, so which is the cosine law. And I think I've got it written back down here. So c squared equals a squared plus b squared minus 2ab cos c. So notice the c's at the front and the c's at the end. This time I'm going to do the same thing, but I'm going to have the x in the front, so x squared equals y squared plus z squared minus 2yz cos capital X. Now I'm okay because I have the little y, I have the little z, and I have the big X, so I can use it. Okay, so I'm going to go ahead and substitute my values in. Okay, so I substituted in, and I saw y. I'm going to make sure I use the 8. The z is the 5, and I can easily see from the equal signs lining up exactly what the y, z, and big X are. Okay, then I need my calculator. I can do this all in one shot if you want, or you can do it in pieces. But 8 squared, so I'm going to go over here. So I got 8 squared plus 5 squared minus 2 times 8 times 5 times cos of, I forgot, I think it's 120. Whoops, 120. Okay, and I get 129. So that's, remember, x squared is 129. So if I want x on its own, I'm going to have to take the square root of both sides. That's why I like using a different color. And I'm left with x equals, and I go back to my calculator here and do the square root of the previous answer, and I get 11.35. 11.35. And the units were in meters, so this must be in meters. In fact, this was in meters squared, and then we took the square root, we got into meters. And note, that's got to be the biggest angle. There's no way these angles are going to be bigger than 120, so that'll be the biggest side, so I'm happy with that. Okay. Okay, another kind of question here. Again, I didn't give the which one is which, so we're just going to go ahead and say P, Q, and R. But if they're given in the question as P, Q, and R, which one is which, you need to be careful. Across from big P is little p, across from big Q is little q, and across from big R is little r. Okay, so again, I like the sine law better than the cosine law. I'm going to try that one. So I'm going to write it down as we're looking for a side. So I'm going to say P over sine big P equals Q over sine big Q equals R over sine big R. And then I'm going to say, what things do I know? Well, I have big P, I have big R, I have little p, I want to find q. Okay, and then I realize I don't have enough information. I wish it was this one, but I could find big Q if I wanted to, because I know that if I add the three together, it'll equal 180 degrees. So I could say Q plus P plus R equals 180, Q plus 75 plus 65 equals 180, Q plus 140 equals 180. I'm going to minus 140 from each side. And I'm left with Q equals 40. So now I know big Q, so I'm good to go. Okay, so then I'm going to go ahead and substitute. Instead of little p, I've got 15. Note the units are feet. I do not need to change this to inches. 15 feet are fine. I would change to inches if it was 15 foot 3 inches, but if it's just 15 feet, I'm going to leave it. And sine big P is 75 equals little q, I don't know, over sine big Q, now I know, is 40 degrees. I want Q on its own, so I say what's near it is that sine 40, and I'm going to multiply both sides by sine 40. I've got a sine 40 on the top and a sine 40 on the bottom. They divide each other out and I'm left with 1. And I'm left with Q equals sine 40 times 15 divided by sine 75. Okay, so sine 40, and close that bracket there, times, I forgot already, 15 over sine 75 times 15 divided by sine 75, and I'm left with 9.98. Okay, I'm going to write the 9.98, and it's feet, but that's pretty much 10 feet. Okay, if it was a word question, we'd do a word answer as well. Okay, this next one is going to be one of those two-steppers where the top triangle we need to work out to get to the bottom triangle, because I don't have enough information in the bottom triangle. I'm trying to find that angle. But wait, that's the exact same diagram as the previous one, and we already worked out Q. So we could say step 1 is done on previous page. Okay, step 1, previous page. Okay, now we're into step 2. So I know that this was 10 feet. Okay, this is 20 feet and 14 feet. So I'm looking in the bottom triangle. Okay, I'm looking at triangle PRS, and I'm going to redraw it. Try to redraw it. S, P, and R. And I know that's a 10, 20, 14. And that's a less. And this is little r over here. And this is little p. And I want to find big S, okay? So I'm looking at cosine law. I don't have enough for sine law, but I can go through cosine law and say that S squared equals r squared plus p squared minus 2rp cos S. And I'm going to go ahead and substitute. And I did a little split screen here so that I can see them both at the same time. So I definitely know that 10 squared becomes 100 equals, and then on the other side I'm going to combine some things together, right? So I can double check my 10 squared is definitely 100. Okay, so now I've got 20 squared plus 14 squared is 596. I'm going to write that one in. 596 minus, so I've got 2 times 20 times 14. It's 560. 560 cos s. And I want to get the cos s on its own, so I'm going to minus both sides by 596. And I'm left with, so I got 100 minus 596 is negative 496, right? Negative 496 equals negative 560 cos s. And I want cos s on its own, so I'm going to divide both sides by that negative 560. And I'm left with negative 496 divided by, so the answer divided by negative 560, oops, 560, gives me this weird looking number, 0.8857. And if I want s on its own, I'm going to inverse cos both sides. And I'm just left with, okay, so we do inverse cos, so function inverse cos of that answer is the easiest way to do it rather than trying to type in part of it, is 27.7 degrees. 27.7 degrees. Okay, going to look at another type of question where it's a word question. Okay, I've pre-drawn the part of the diagram and we're looking for a few different things. How high on the wall does the ladder reach? First off, the ladder is 5 meters long, so that's the length of the ladder there, leaning against the vertical wall, making an angle of 65 degrees with the ground. So that's the angle down here. We know that's a 90 degree because that was a vertical wall. And we're looking at a few things. How high does the water reach? So that's this one. How far is the foot of the ladder from the wall? That's this bottom one. And what angle does the ladder make with the wall? Is this other one. So because it's a right angle triangle, I'm going to go ahead and label this thing. Hypotenuse first, that's the longest side across from the right angle. Opposite is going to be opposite this 65 because I'm going to do my calculations with that, and the adjacent is the guy left over. And if I call this capital A down here, and maybe I'll call this one capital B at the top and capital C at the bottom, that leaves me with, if capital A is there, little a is over here, and it happens to work out, that's the same answer as little a. If capital B is at the top, then little b is at the bottom. That happens to be what the question of little b is. And if capital C is at the corner here, this is little c over here. That's not the angle C, but that's okay. All right, so I need to do 3 things. Let's work on them one at a time. So for A, we're going to find actually A. Just happened to work out that way, okay? And I know that it's a right angle triangle, so I can use SOHCAHTOA. And I want to identify, what do I have? I have the angle. I have the hypotenuse. In the first case, I'd like to find the opposite. So I'm definitely going to take this equation. Okay, so I've got sine theta, write the formula first, equals opposite over hypotenuse. Sine, the angle has to be 65. Even if I knew what the other angle was, I still have to use the 65 because I labeled the triangle that way. Opposite is little a, hypotenuse is 5. We don't want little a on its own. Some people start multiplying both sides by a. That's not going to get you anywhere. That'll get you a squared over 5, and you're no better off. If I multiply both sides by 5, remember that 5 is now above the line. So I got 5 divided by 5 is gone. I'm left just with a equals, and 5 times sine 65 ends up being 4.5, and I do need some units. This is in meters, 4.5 meters. Okay. Question B says we need to find, in this case, it actually happens to be B because it's how far the foot is from the base of the wall, okay? So in B, I still have the same things I know, but now I want to find little b, which is the adjacent. I'm going to have a little question mark next to the adjacent, okay? And which of the 3 ones do I want to use? I'd prefer to use the cos one, okay? I do know the opposite now, but I'd rather not use that calculation. I do know it now, but I'd rather not use it because what if I made a mistake? Plus, I like the adjacent because it's on the top of the fraction, makes life easier for me. So I've got cos theta equals adjacent over hypotenuse. Cos 65 equals the adjacent, who is b. Hypotenuse is 5. Sorry, I'm squishing it a little bit. I want b on its own, so I'm going to multiply both sides by 5. and 5 divided by 5 is 1, so I'm just left with b equals 5 times cos 65 is 2.1 meters. Okay, and then the part C, we're going to find angle B, right? What's the angle between the ladder and the wall? So now we know that A plus B plus C equals 180, angle sum of a triangle theorem. So 65 plus B plus 90 equals 180. I've got B plus 65 and 90, I think is 155 equals 180. I want B on its own, so I'm going to get rid of that 155 by taking 155 away from both sides, and left with B equals 25 degrees. Okay, here's another challenge one for you. So this person's flying at 700 kilometers an hour. For part of it, she flies for an hour and a half, and then she flies somewhere else for 2 hours, okay? So she's flying along, turns a little bit to the left, and then flies for another 2 hours. So let's work things out piece by piece here. Okay, so if she's traveling at 700 kilometers an hour, because we're looking for distances, how far we're looking for distances, we're not looking for final speed. In fact, your speed doesn't change, so we're looking for distances. 700 kilometers times 1.5 hours is going to be, 700 times 1.5 is 1050 kilometers, 1050, and 700 kilometers times 2 hours should be 1400 kilometers, okay? And now we need to draw a diagram, and so we're going to go ahead and say she's going to start going, we'll call it north, it doesn't really matter, this way, and then she's going to, I'm going to put some dotted lines here. She's going to veer off by 8 degrees. So it's not very, I'm going to make it exaggerated more than 8 degrees to make the triangle look nicer, but it's not very much. Okay, and she goes for a little bit longer. I'll make that line a little bit longer. Okay, oops. So that's 8 degrees in here. And this was 1050 kilometers. If that's starting point A, at point B, she hangs a left, and then she travels for 1400 kilometers. And they want to know, we'll call that point C if you want, we want to know how far it was from start to finish. I'll make it in a different color. From there to there is what we want to know. And since we're labeling these things, capital A, capital B, capital C, we could call this thing little b and little c and little a. And if we knew that's 8 degrees, but all the way around there is 180 degrees to make the straight line, so this must be 172 degrees. Oops, I even had it typed over here for me. Okay, there's 172 degrees. There was my 8 degrees right there. Okay, so I've got this crazy looking triangle, and I'm going to use cosine law. I'm going to write it out. I know I want the b, so I'm going to start with the b. B squared equals a squared plus c squared minus 2ac cos big B. And I go ahead and write everything in. B squared equals little a was 1400 plus 1050 squared minus 2 times 1400 times 1050 cos 172. And I can put that all in the calculator in one shot if I want to, or I can break it up into pieces. It's up to you. Okay, so I've got b squared, though, remember, is equal to, so I got 1400, whoops, 1400 squared plus 1050 squared minus 2 times 1400 times 1050 times cos of 172. Okay. So I got this crazy long number. So b squared equals 5973888. That's actually kilometers squared, but I want b on its own. So I'm going to take the square root of both sides. I'm left with b equals, and that's why I love the Desmos. I can say square root of whatever that answer was, and I get 2444 kilometers. And we're done. And last one. So sine x equals a half. I can do this on Desmos and say if sine x equals a half, well, if I want x on its own, I can go ahead and do sine -1 of both sides and put it before instead of after. I know some people are trying to write it afterwards. And I'm left with x equals, what's the inverse sine of a half? So I go to my calculator, function sine -1 of 1/2, I get 30 degrees, okay? But I know that's not the whole story. If I go and graph this thing, y equals sine x, and remember I have to change, whoops, I have to change my settings to make sure this is in degrees, not radians. Radians is a different form of measurement for angles, to 360 degrees. Oops. I like to show step 30, just it goes in 30s, and the y is going to go from negative 1.1 to 1.1, just so I can kind of zoom in on the whole thing. Okay, so y equals sine x. There we go. And it said if y equals sine x and y equals a half, oops, I'm going to grab the second one, say y equals 1/2. Where they intersect gives me the answers. So 30 degrees works, but that's not the only answer. There's also an answer over here at 150 degrees. So I'm going to go back here and say, or x equals 150 degrees. So the calculator only gives you the first one, but there's multiple answers. In fact, there's more answers if I kept going to the right or going to the left as well. Okay, so the second one says cos x equals negative root 3 over 2. So I'll try it on here first. Cos x equals negative root 3 over 2. So I want to find x on its own. I'm going to do cos negative 1 to both sides. Inverse cos of negative root 3 over 2. So inverse cos of negative root 3. I'm going to use my arrow key to the 1 to the right to make sure I get out of the root sign there, over 2. And I get 150 degrees. But again, I could, if I'm ambidextrous, if I wanted to graph this, and I can turn these graphs off so I only see this beat. Y equals cos x, and I want y equals negative. For square root, I'm going to do SQRT, and it pops in the square root of 3. Whoops. Arrow to the right, divided by 2. And now I'm looking for, definitely the answer 150 degree works, but there's also 210 degrees over here. So that or x equals 210 degrees. But the only one that satisfies both is 150 degrees. So I'm going to say therefore x equals 150 degrees. And if I graph them all on the same one, it gets a little messy, but I can see at 150 degrees. In fact, I'm going to go ahead and say x equals 150 is going to show me there's the first one and there's the second one down there. Okay, it gets a little crazy with all those graphs on there, but 150 degrees satisfies everything for me.